Hi, this is Ms. Sigala, and this is your homework for 1.1 1.2, which is due on Tuesday, September 2nd. You will need your pencil and a calculator. Alright, so last week we talked about conversion factors, what dimensional analysis is, and the units of measure, or the metric system that we'll be using. Make sure that you show all your work. Remember, an answer is not going to be acceptable. Alright, so in our first calculation, we have 500 grams, and we want to figure out how many milligrams are in those 500 grams. So the very first step that we covered last week was always start off with your given. In this case, we have 500 grams, which is our given. I want to figure out milligrams. We check our table, and do we have a direct link between grams and milligrams? And we do. Next, we're going to make sure that we write grams in the denominator because we want to be able to cancel them out, and milligrams in the numerator. Now, what's my equality that exists between milligrams and grams? I have 1,000 milligrams is equal to 1 gram. Am I happy with milligrams? Yes. I can now write my equal sign. Because grams is now my denominator, I can cancel them out, so this is a unit that I'll be using. Okay, that was a long bell. Alright, so then I check with my calculator, and I take 500 times 1,000, and I end up with 500,000 milligrams. Okay. And go ahead and please write down your answer, which is 500,000 milligrams. Okay. All right, number 2 is asking us how many centiliters, remember the C stands for centiliters, are in 0.03 liters. So again, my first step, I write down my given, 0.03 liters, and I want to cancel out liters. So I know liters is definitely going to go in my denominator. Now, next I look, well, is there a direct link between centiliters and liters? And there is. Okay. Remember, liters is your basic unit. It can be centimeters, centiliters, centigrams, okay, and that's going to be the same. So that means that we have 100 centiliters are equal to 1 liter. I can now cancel out my liters. Am I happy with centiliters? Yes, I am. Okay, so now I can write my equal sign, and I take 0.03 times 100 because I'm going to be multiplying directly across because it's multiplication, and I end up with 3 centiliters. Okay, so my answer would be 3 centiliters. All right, my next problem, I have 344 milligrams, and I want to know how many kilograms that equals to. Well, let's see how many steps this one will take. So again, write our given, 344 milligrams. I know I have to get rid of milligrams. So milligrams is going to go in my denominator. Now, is there a direct link between milligrams and kilograms? Unfortunately, there isn't. So I need to use my basic unit to get there, which is grams. How many milligrams are in grams? I look at my table and I see that there's 1,000 milligrams in 1 gram. I can now cancel out my milligrams, but I'm left with a gram. Am I happy with gram? Nope, I sure am not. So then I'm going to cancel out my grams by putting it in the denominator. And I want to get to kilograms. Is there a link between kilograms and grams? There sure is. We have 1,000 grams is equal to 1 kilogram. Now I can cancel out my grams, and I'm happy with kilograms. I can now write my equal sign. Okay. And since I'm multiplying fractions, remember, you're going to multiply your numerator times your numerator times your numerator, and then you're going to multiply your denominators times each other. So I'm going to do this in a bit of a longer step so you can make sure you understand. So I have 344 times 1 times 1. I'm still going to have 344 kilograms because that's my unit. Over I'm going to take 1,000 times 1,000, and that's going to give me 1 million. Now, there is no unit left in my denominator, so that's why I don't carry over a unit. So I have this fraction now, and because I have 344 over 1 million, now I divide 344 divided by 1 million. And that gives me, well, my calculator, it's going to give me 3.44 e to the negative 4. You might not know what that means yet, and that's okay. Go ahead and write this answer down. Okay. And don't forget your units. It is still kilograms. Okay. All right, our next problem, we have centimeters to meters. Are given 0.004 centimeters, and we want to end up with meters. We want to cancel out centimeters, so centimeters goes in my denominator. Is there a direct link between centimeters and meters? There sure is. 100 centimeters is equal to 1 meter. Again, we can cancel out our centimeters. We're happy with meters? Yes. So now we can write our equal sign. Now we end up with 0.004. My unit is meters. And I still have a denominator. My denominator is 100. So then I'm going to take 0.004 and I'm going to divide that by 100. And that will give me 4 e to the negative 5th. Don't forget your unit, that's going to be meters. 4 e to the negative 5th meters. Alright, next problem, we have 4 centimeters and we want to get to millimeters. Again, 4 centimeters is our given. We want to get rid of centimeters, so it goes in our denominator. A link between millimeters and centimeters does exist. You have to be careful here though, because remember, to go from centimeters to millimeters, you have to divide by 10. What that means is that we have 10 millimeters in 1 centimeter. Okay, we can now cancel out our centimeters. We're happy with millimeters. Okay, so again, we're going to multiply our numerators. 4 times 10 is 40. We only have 1 in our denominator, so we don't have to do anything about that. So our answer would be 40 millimeters. Okay, my next problem says we want to go from 318 centigrams to hectograms. Okay, how are we going to do this? Well, we must make sure that we use our basic unit. In this case, it'll help us out. And let's start with our given first, 318 centigrams. We want to multiply. We want to make sure we get rid of centigrams first, so it's going to be in denominator. And we know that our basic unit is grams, so we're going to put grams up here. How many centigrams are in 1 gram? We have, remember, centi means 100. Alright, we can cancel out our centigrams. But we're not quite happy with grams. We want to get to hectograms. Alright, so then we want our next step, we want to get rid of grams. Well, to get to hectograms, we have to make sure that we know that we have 100 grams in 1 hectogram. And why does that happen? Because remember, each time we go up, in the next step up, it would be deca, we multiply times 10. Then we multiply times 10 again, and we end up with hecto. So now we can cancel out our grams, and we're happy with hectograms. I write my equal sign, and now I'm going to set up the problem. my numerators, I have 318 times 1 times 1, so that's going to give me 318 hectograms, but I still have my denominator to worry about. So 100 times 100 equals 10,000. So I still have to divide 318 divided by 10,000. And that's going to give me 0.318, 0.318 hectograms. So I'm going to write it here, 0.0318 hectograms. Alright, next problem. We have 12, and this is actually a typo. This is supposed to be a lowercase dl. Okay, so that way we know that if it's lowercase, if you look at your notes, that stands for deci. Okay, so in this case we have 0.12 as our given deciliters. We want to get rid of deciliters, and we want to end up with kiloliters. It's going to be a little bit longer. So we write deciliters in our denominator because we want to get rid of it. But then we're going to use our intermediate step, in this case, which would be our basic units. So how many deciliters are in a liter? Deci, remember, 10 is equal to 1 liter. We can cancel out our deciliters, but we're not happy with liters. We want to get to kiloliters. So we multiply, and we use another step, liters in the denominator, kiloliters in the numerator, because there is a direct link between the two, and we know that there's 1,000 liters in 1 kiloliter. We can now get rid of our liters because we're happy with kiloliters. And again, we have our numerator, which is 0.12 times 1 times 1. And we have our unit, kiloliters. But then we also have to multiply our denominators. So we have 10 times 1,000, which is 10,000. So now we take our numerator, because it's a fraction, we have to take 0.12 and divide that by 10,000. And that's going to give us 1.2, and then an e to the negative 5th kiloliters. You can have that. You can have 1.2 e to the negative 5th kiloliters. Or this can also be written as 0.12 kiloliters. A very, very small number. Okay? Alright, but we'll cover that. We'll cover scientific notation next week. Alright, so our next problem, we have meters. We want to get to hectometers. So again, start off with your given. Our given is 92 meters. We want to get rid of meters, so it's going to go in our denominator. Is there a direct link between meters and hectometers? Well, we know that hecto, again, means 100. So, yes, we have 100 meters in 1 hectometer. So now we can cancel out meters and meters. We're happy with hectometers? Yes, we are. So 92 times 1 is 92 hectometers over 100. So 92 divided by 100, we have 0.92. And the unit is hectometers. So 0.92 hectometers. Alright, our next problem, we have our given 105 milliliters. And we want to get 2 liters. We look at our table, and how many milliliters are in a liter? Well, it says we have 1,000. Oops, sorry. It says we have 1,000 milliliters. Milliliters again in the denominator because we're going to get rid of it. We have 1,000 milliliters in 1 liter. We can now cancel out our milliliters. And again, 105 times 1 is 105 liters, but our denominator is still 1,000. 105 divided by 1,000, we end up with 0.105 liters. Alright, our last problem for this section, our given is 2,674 centimeters, and we want to end up with kilometers. Again, we want to get rid of centimeters, so it's going to go in the denominator. And we don't know how many centimeters in a kilometer, but we do know that there is a link between meters when we get to our basic units. And we know that we have 100 centimeters in a meter. We can now cancel out centimeters. We have meters, but we're not happy with meters. We're going to get to kilometers. So now this unit will help us know how equality will be written. We want to have meters in the denominator because we want to cancel that out. Is there a link between meters and kilometers? There sure is. We know that 1,000 meters is equal to 1 kilometer. We can cancel out our meters, and we're happy with kilometers, so now we can write our equal sign. So again, we have 2,674 kilometers, because we multiplied all of our numerators, over, and now we're going to take 100 times 1,000, and that's going to give us 100,000. No units, because we canceled it out. So now we're going to divide our numerator, 2674, and divide that by 100,000. And that's going to give me, I'm going to go ahead and write my answer. It's going to be 0.02674 kilometers. Alright, the second half to our homework, it's a little bit more challenging. And so, because we have some units that we haven't used probably since 8th grade. So the first problem says convert a density of 9.45 grams per liter to its equivalent, but we want to use grams per milliliter. Okay, it's going to be a little bit different, but you have to allow the unit that you want to get rid of to guide you. So again, we're going to start off with our given, and our given is 9.45 grams. Now, this is over 1 liter. Okay, it's kind of like miles per hour. And so that's our given, and we want to find out milliliters. Okay. So we're not going to be messing with the grams at all. Okay, so you want to know, well, we know we want to get rid of liters, and we want to end up with milliliters. Is there a direct link between liters and milliliters? There sure is. We know that 1 liter is equal to 1,000 milliliters. We can now cancel out our liters. Are we happy with milliliters? We are. So now we can write our equal sign. We're going to end up with 9.45 grams because that unit is still here. So you're going to transfer it over because it's still in the numerator. But in this case, now we have a unit left over in the denominator, which is perfectly fine. So we're going to write down 1,000 milliliters. But now we have to do our math. So 9.45 divide by 1,000 is going to give us 0.00945. We have grams in the numerator and milliliters in the denominator. Okay, this one's a little trickier. Number 2. Now we have the density of lead, which is 11.3 grams per milliliter. We want to know the mass of 45 milliliters of this metal, but in grams. Alright, our next problem is a little bit more complicated because we have to decide what information is our given, and then what other information are they giving us to help us get our answer, okay? So then it says the density of lead is 11.3 grams per milliliter. What is the mass of 45 milliliters of the metal in grams? So in this case, we have to figure out that our given is actually 45 milliliters of a metal. And we want to find out the mass, okay? But the mass, we want to know it in grams. So our given is 45 milliliters. And we want to know the mass in grams. Well, in this case, we know that the information that's given to us, they give us 11.3 grams per milliliter. Okay? So we want to get rid of milliliters. So milliliters will go in our denominator, and we want to end up with grams. So then in this case, because grams is on this side of the little dashed line, that means it's in the numerator. So it's 11.3 grams for 1 milliliter. We can now cancel out our milliliters, and we can do our math. So 45 times 11.3 is 508.5. Which unit survived? We have grams. Okay. Our next problem, we have a solution of barium nitrate contains 61.2 grams per liter of solution. How many grams of barium nitrate is contained in 2.75 liters of this solution? Alright, so in this case, we have to know that, we have to figure out many pieces of the puzzle. We have to know that 2.75 liters is our given, and we also have to know that this information will help us get to our answer. Now, since it's 61.2 grams per liter, we also have to know that this can be written in a different way. It can be 61.2 grams per liter, or you can also write it down as 61.2 grams over 1 liter. Let me fix that 1 over 1 liter. Okay, so these are two ways that we can write it. So now we write our given 2.75 liters, and we want to end up with, what do we want to end up with? We want to end up with grams. We want to get rid of liters, so we know that we're going to make sure that liters is in our denominator, grams is in our numerator, and it's going to be 61.2 over 1 liter. We can get rid of our liters, so 2.75 times 61.2 is going to be 168.3 grams. I'm happy with my units, so I can stop there. Alright, our next problem says a sample of seawater contains 6.277 grams of sodium chloride per liter of solution. How many milligrams of sodium chloride would be contained in 15 milliliters of this solution? Alright, this is probably the most difficult problem. Alright, so we have to figure out information. Okay? Our given in this case is 15 milliliters of the solution, and this 6.277 per liter, we have to know that that information will help us get somewhere. So you're going to write down 6.277 grams, again, per liter, or remember, this means that this is in the numerator and this is denominator. Okay. So how many milligrams? So that's not even here because we have grams. We don't have milligrams. So let's see what we have to do. So again, our given, 15 milliliters. Okay. Now here they gave us liters. Okay, so first we must convert to liters. So we want liters. We want to get rid of milliliters. So 1,000 milliliters is equal to 1 liter. So we can cancel out our milliliters. So we end up with 15 divided by 1,000 because, again, we're multiplying directly across. Liters, 15 divided by 1,000, 0.015 So now we have our correct unit. So now we can get rid of our liters, 1 liter, and now we're going to use 6.277 grams. Okay, in this case, our liters cancel out. Okay, are we happy with grams? No, because we want to get to milligrams. So we want to cancel out grams, end up with milligrams. How many milligrams are in a gram? We have 1,000 are equal to 1 gram. We can cancel out our grams, and now we're going to do our math. So now we take 0.015 times 6.277 times 1,000. And that's going to give us 94.155 milligrams.